Of all the fraction operations, division is considered to be the most challenging. Not necessarily for the methods that we choose to solve it, but mainly because of the idea behind the intuition of what it means. We can all think about 6 divided by 3, which is 6 items shared 3 different ways. So we get 3 groups of 2. So 6 divided by 3 is 2. We could even think about 2/3 divided by 2 because, well, that's just as good as having 2 things, and it doesn't really matter that it's a fraction, you still end up with one of those things. So 2/3 divided by 2 is 1/3. It's pretty easy where we can easily split it into whole numbers of groups. You can now see why this is a little bit more challenging. 3/2 divided by 5/4. So split 3/2 into groups of 5 1/4. Yeah. Oh, sorry, not 5 1/4, 5 quarters. It's pretty conceptually difficult at best. So what we do is we rely on a relationship called the reciprocal, which is probably one of the most fascinating relationships in early maths. So a reciprocal is a number that you would have to multiply the subject or the focus number by in order to get to 1. But before we look at the method with the division, we're going to look at what a reciprocal is. Let's question ourselves. Firstly, 3 times what is equal to 1? You probably guessed it, it's 1/3. What we're looking for here is any patterns that you might find to help us remember how to find a reciprocal, and there are patterns. It's quite straightforward. Let's do the first 2 and see if you could see it. 1/7. What would you multiply that by to get to 1? Well, if there are 7/7 in 1, we'd multiply it by 7. Hopefully at this point you can see the 3 and the 3 and the 7 and the 7. It's not coincidence that the denominators are the same as the number that they multiply it by. So in general here, when we have numbers, the reciprocal is 1 over that number. And when we have a fraction which is 1 over a certain number, then the reciprocal is the number on the denominator. So be aware of that. Now let's extend the idea to fractions in general, where there's not a 1 on the numerator. What happens here? Well, 3/4 multiplied by 4/3 is equal to 1. You can see that the 4's cancel, the 3 cancels, and so you have 1. What have we done? In general, we flipped the fraction. And if you want to make it completely generalized, what's the similarity between 3, 1/3, and 3/4? If I write them all as fractions, so 3 could be written as 3/1, and then we've got 1/3, and then we've got 3/4 again. I'll draw a dividing line, and underneath I'll write their reciprocal. The reciprocal of 3 was 1/3. So if you could write 3 as a fraction form, as 3/1, it just flips. What was the reciprocal of 1/3? It was 3, which is 3/1. And remember, 3/1 is just 3. And then the reciprocal of 3/4 was 4/3. In all cases, they have just been flipped. It's just that some of them weren't written in their fraction form. So flipping the fraction is what I mean is changing the numerator for the denominator. How could that be really useful? Well, aside from knowing the reciprocal, it's really useful in the division because of this fascinating relationship here. For this first question, 3/2 divided by 5/4 is exactly the same question as 3/2, and we'll change it here. It's exactly the same as 3/2 multiplied by the reciprocal of the fraction. Brilliant relationship. What it says is that if I divide by a number, it's exactly, and it's not just with fractions, it's with everything. If I divide by a number it's the same as multiplying by its reciprocal. It's a great phrase to remember. So some people like to remember this as KFC. Keep, flip, change. I make no reference absolutely whatsoever to any other thing that might be very popular with regards to K, F, and C. To me, they're just letters, which means keep, flip, and change. Although I never really agreed with that order, and I think you'll see you keep the first, you actually change the fraction, and then you flip the second. Sorry, you change the sign, and then you flip the second fraction. So it should be KCF, but you decide which one is easier to remember for you. So once we've done that, we've kept the first one the same, we've changed this to a multiply, and then we've flipped the second fraction. The answer we get from the multiplication is exactly the same as the division. Rewind that 10 seconds and hear it again. The result is the same. So multiplying, much easier to us, 3 times 4 over 2 times 5. And then is there any understanding needed here? Is there any intuition of what this is? No, we're just following through the motions. We know how to multiply two fractions. So we have our 12 over 10. In fact, that's a mixed number. So it goes in 1 whole times and remainder 2 out of the 10. In fact, we could cancel that down again. So we've got 1 and 1/5. Okay, so there's our final answer. But whether we're changing to a mixed number or not, the main method has happened already over here. Change your division question to a multiplication. Now there are some other intermediate steps that you could try when it comes to these fractions, and you don't always have to end up multiplying the big numbers that come out of them. So for example, we'll do our methodology here. We'll go to red. We'll do our methodology here, and we end up with keeping the first one, changing it to a multiply, and flipping the second. Now you may or may not think that these multiplications are easy. I mean, 8 sevens are relatively easy, 21 4 relatively easy, but it could be difficult, could be bigger, could be more nasty, because multiplying things get big. What you could do is just remember at this stage, before going ahead and just doing it, is to cancel out fractions. So we could write the 8 as 4 times 2. We could write the 21 as 3 times 7, and we've got 7 over 4 on the left there. Now we've got elements on the top and the bottom of these fractions, so we can see we've got a 4 here that can cancel. So we're left with a 2 up the top, multiplying on the bottom of this one, we'll end up with a 1. And on the left here, we've got 3 is 7. The 7s are going to cancel, like so. And so we end up with 3. And that's much easier. We've got 2 over 3. We just go ahead and just check that that would have worked if we did it this way. We get 56 over 84. And then we're thinking about what we're going to divide by next. It looks like 7 could be a good one without going too hard. 7 goes into 84 12 times, and 7 goes into 56 8 times. And then we can see dividing by 4, we get our 2/3. So it is going to be the correct answer there. You've got to decide whether you'd prefer to go down the equivalent fractions road of dividing, or whether you want to do something a little bit tricky here and cancel down beforehand, depending on what you want to do.